Hello, this is Engineering 6, Group 8, presenting to you card games. Our particular card game is blackjack, and on my left is Anthony, who will be playing as player 1, and on my right is Senjo, who will be playing as player 2.
Okay, I'm going to confirm player 1 right now.
And I'm going to confirm player 2.
I'm going to bet 300.
And I'm going to bet 200.
I'm going to draw my starting hand.
And I also draw my starting hand.
Okay, so I'm going to hit, and I bust.
And I'm going to hit. And I'm going to hit again.
Huh?
And I'm going to hit again.
Alright, we continue again.
And also continue again.
I'm going to bet 200.
And I'm bet 400.
I'm going to draw my starting hand.
And I also draw my starting hand.
So I'm going to hit. Now I'm going to stand.
I'm going to hit. I'm going to hit again. And I'm going to stand.
Okay, so the dealer has draw.
And the restart game button will just set the game back to square one, which means it will generate new players, everyone will get 500 in their bank account again, and they could just start from there. And that's the end of the demonstration of the game.
6, Group 8, I'm Anthony, and I'm going to explain all of our callbacks for our blackjack game. So first we have a startup function, which has all these think speak commands here, and then resets the turn counter, which is the number of cards the player has, and creates different objects for each player. An object for the deck, the dealer sets the dealer to player number 3, and card finder to 0, and resets all of the images and text to 0 and the back of the cards. Our confirm player button pushed is for think speak purposes. One person needs to be player 1 and one person needs to be player 2 to successfully transfer the data back and forth with each player. So player button 1, bet button pushed. This callback refers to the bet button underneath the bet amount text box. So what happens here is it takes the value that the player wants to bet in the bet amount, and it checks to make sure they actually have enough money in their bank account to bet it. And once this is done, it sends the data to ThinkSpeak, and it's player 2's turn, and they also do the same betting. So the draw hand starting button pushed callback, this will give 2 cards to the player that pushed it, and then send the turn to the other player. In this function, it will also call the calculate hand value button, calculate hand value function, which will calculate the hand value based on each card. Each card, the number of the card is the value. Face cards are 10, and an ace is 1 or 11. The hit button pushed will draw a card for each player with sounds for drawing, and it'll calculate the hand value again, and go from there. If the hand value is above 21 after it's newly calculated, it will just pass the turn to the next player. The stand button just transfers the turn to the next player. And then hit button 2 and stand button 2 are the same callbacks, but for player 2. They will draw a card for player 2, or they will stand for player 2 and pass the turn to the dealer. Continue button push callback, this is after the dealer plays. It will just continue the game from where you're at, reset everyone's hand value and cards, and they will keep their bank account though, so they're able to keep going and keep betting. Restart game button push, this callback will completely reset the game to scratch.
Okay, I'm Shengzhou, and I'm doing the part of the song, so you can see it has the function that will read audio of the blackjack and the Wawa. If it buzzes, it will read the Wawa song. And it is the card flip song, and if you draw your cards, it will auto read the card flip song. And every time you draw, and it will...
To explain to you how we implemented ThinkSpeak into our app. So first we have a function called wait for data. which pretty much makes whoever runs this function be stuck in a while loop, waiting for a data from ThinkSpeak that isn't from themselves. So we check player who sent message is not at the other player number, and if it is at the other player number, it'll exit the while loop and continue the rest of the function. And the data that's being sent to ThinkSpeak is separated in these little categories. So first is player number, the bet amount, the bank account, their hand value, their status, and the card indexes. The wait for dealer app is pretty much the same thing as wait for data app. However, it is more specialized to wait for dealer's data type, which only has 3 values to it. So update client dealer is pretty much to update your own client's dealer from ThinkSpeak, which will take whatever cards are in the data, index it into their own deck, and update the client from there. The update clients app takes the data from ThinkSpeak, check who sent the data, and depending on who sent the data, it'll update whoever's value. So for example, if player 1 sends data to player 2, the message containing will contain player number 1, which means that the client of player 2 will update their player 1's properties. So first it will check the status of player 1. If player 1 status is 2, that means they are in an unplayable state because they have stood. It will prevent any card indexing, which will prevent deletion of unnecessary cards. However, if player 1 is in a playable state, which is 1, or which is 0, it will then run this entire function from here on out to index the cards they got from ThinkSpeak, and then run this to show the cards into the GUI and update client-side values. And same thing if it were to be player 2 updating, same thing if it were to be player 1 updating player 2's status, or player 2's values. And send data dealer will just send the data from the dealer that we got from player 2. Send data pretty much just sends the client's values. So for example, if you're player 1, you will be sending player 1's values. So first it will check what player number are you and your status. If your status is 2, that means you are in an unplayable state because you stood. You won't be sending any card indexes. And then here is the right key. And then this is the clear ThinkSpeak channel. And here is our game. So when player 1 confirms the player button, so this Google Doc basically contains really specific instructions in order to visualize how ThinkSpeak is going to work. So first, each player selects their own player number, and depending on what player number they select, every time they do something, it'll change the behavior of the function. So for example, when player 1 does something, it'll be different than if player 2 were to click the same exact button. So after each player confirms their confirmed player button, player 1 will pretty much be in a state to be able to start betting, while player 2 will be stuck in a while loop waiting for player 1 to do something. When player 1 enters the amount of money to bet and presses the bet button, the player 1 will disable their own bet button, send the data to ThinkSpeak, and then waits for player 2. When player 2 is over here while stuck in a while loop, they receive player 1's data. They enable their own bet button, enters the bet amount, and sends data to player 1. And this is what happens when player 2 enters the bet amount. Player 1 receives player 2's data, and it enables the start button for player 1, and then player 1 presses start. So when the start button is pressed, player 2 is stuck in a while loop to gather data. Player 1 receives a card, deck gets updated, and player 1 sends updated deck and the cards to player 2. Player 2 is no longer in a while loop. Player 1 will be in a while loop to gather data. Player 2 receives the cards, deck gets updated, and player 2 sends updated deck and the cards to player 1, and player 2 will now be in a while loop again. So after the start game function is executed, player 1 presses the hit button, they receive the cards, they update their deck, and they could be in 3 states. They could be in a playable form or in a busted state, or in an unplayable state, which is either being in a state of stand or in a state of being a busted state. They will send their state and everything else to ThinkSpeak, and then player 1 can still hit if they're in a playable state. But if they're not in a playable state, their own buttons are now disabled, and they will be stuck in a while loop to receive data. If player 1 stands, they will send ThinkSpeak the cards, the updated deck, and the current state stand. Player 1's button will now be disabled, and player 1's will now be in a while loop to receive data. And then now it's player 2's turn. Or this is the scenario for player 2 when player 1 presses the hit button. So player 2 is stuck in a while loop. They receive the data from player 1. They update their client side player 1 with player 1's card and updated deck. And then they check if player 1 is in a playable state or in a busted state. So if player 1 is still in a playable state, they have to remain and waiting for data. If player 1 is in a standing state, they will exit the while loop and update player 1's status. And if player 1 is in a busted state, they exit the while loop and update player 1's status as well. And so here, player 1 is in a while loop because they either busted or they stood. Player 2 will hit, they receive the cards and their updated deck. Player 2 will now be in some state of being either playable or not. Player 2 will send ThinkSpeak their cards, updated deck, and their current state, and they will disable their own button. So right after player 2 becomes in an unplayable state, player 2's client-side dealer now plays, or player 2's dealer now plays, and the dealer is a function. And so when dealer plays, dealer will grab cards until they reach hand value of 17. And once they do that, player 2 will